Okay, so Java I-O stands for Java Input and Output. And every programming language has to have some sort of input and output. Remember, that's what defines what a computer is. You have to have the input, that processing, and the output. And computers would be very boring if all of our input just came from the keyboard. Okay, we couldn't have, form input, we couldn't do giant data analysis, which is actually a huge and growing field. Large data analysis or big data analysis. You can make a ton of money doing big data analysis because we have all this data. We're surrounded by lots of data now, right? We have all these sensors, we got all these computers collecting data. They collect all the data you guys use to surf online, anything that you've ever looked at, all the email that you've ever sent, any URL that you've ever looked up is in a file with your name on it at Google. Okay, so they have like huge amounts of data. And in order to get any information out of that data, you do have to analyze it. So we're going to learn how to write files and read files. And the types of files that we're going to read and write are just going to be plain old text files. Okay? All right, so let's jump into this. When we talk about input and output in reference to a computer, they usually call them streams. You'll have an input stream or an output stream. So a stream is a communication channel that a program has with the outside world. Okay. It is used to transfer data items in succession. So is our keyboard, when we're typing things into the keyboard and we're using that scanner object to get input, is that scanner object getting input from the keyboard a stream? Yes, it is. Okay. Anytime we get any type of input, whether it be from the keyboard, whether it be from sensors, whether it be from a web page form with a text box, whether it be from a file, from either a server or from our local file system, these are all streams. So anytime ones and zeros come into your program, it's called a stream. Okay. And an input stream means the input is coming to your program. So remember that your input and output is in reference to where you are, and you are the program. So when data is coming into your program, it's your input stream. And when data is going out of your program, whether it be to the monitor or to, it could be, your output could be lights turning on, your output could be anything, but your output is from your program. All right? So many different ways to have input and output. And for our programs, our input will be from a text file and our output will be to a text file. Okay. Streams support many different types of data. You don't have to use just text file. You could use bytes. You could use primitive data types, characters. But note that in here we're just going to use text, but there are lots of different possible ways to have input come from your computer. Okay. And here's a visual representation of a stream. Now, is this an input or an output? Yeah, it's input because it's going to our program. So from a data source to our program is our input. And then here's a visual representation of output. So from our program going somewhere else. Okay. All right, in order to do input and output in any programming language, including Java, you usually use pre-written libraries. Okay, that's called the Input-Output API, Application Programming Interface, which is a definition of our input-output library. So the Java input-output library is called the java.io package. It contains all the classes that we can use in our programs to read and write our data. So just like every other programming language, When you're reading and writing data to text files, it's pretty much just a copy and paste of that code. Okay, you're not going to change up that code except for the part where you do something with that data, but actually connecting to that file, reading from that file is pretty much a copy paste of code. Okay? Okay, this slide here just says, hey, you don't have to have just text come in from a file. You could have these things called byte streams and interpret those bytes as something other than characters or something other than text. Okay? So here is an example of what our code looks like. Okay. So note that we're going to have some text file. So some file with some text in it. And it's going to be read into our program right here. So here's our code, what it's going to look like. You don't have to have the user enter in a file name. You could hard code this file name. Right? But what we're going to have is something called a try-catch block. So in Java, Java is a very safe language, meaning that if you do something wrong, it will yell at you and not let you do those things that are wrong. Okay? And when we try to read from a file, what are some things that could go wrong when you're reading from a file? What do you think some things that could go wrong? What if the file wasn't there? Matthew?
Cat or the file might be embedded in something malicious.
Right, the file could have something malicious inside of it. The file could not be the data that we expected it to be. And one of the main problems, you know, would be if the file wasn't there. If I'm saying, hey, go read from this file, and the file's not there, then we're going to have a fatal error in our program. Because when I come down here and I say, hey, give me the next line in that file, if it didn't ever connect to the file, you will have a fatal error. Okay? So, Java safeguards you and says, well, if this file isn't there, or I have trouble connecting it, maybe you don't have the rights to access this file, it's in a folder where you don't have rights to access it. If something goes wrong, anything that goes wrong, I'm going to give you back this file not found exception. So it's called throwing an error. It's going to throw this error or throw this exception. It's called throwing an exception or throwing an error. Okay? So you put the part of the code that could throw the error, which is the instantiation of our new input stream. Okay? So this line of code could throw that error. So the line of code that could throw the error goes into what's called a try block. So in other words, you're just saying, hey, try this code out. If it throws an error, catch that error right here. Okay, so if this line of code throws an error, this line of code will catch that error. And the name of the error that it could throw is called the file not found exception. So this is actually called an exception. An exception is an error. And so if it can't find that file, it'll throw the file not found exception. When this line of code can't find the file and it throws the file not found exception, it'll catch it here. In fact, we'll throw these errors today. And then you can recover from that error. You could ask the user to enter in a new file name. You could, go to a different part of your program. Now, because we don't do a lot of error checking, what we do when we can't find the file, we just output a message and stop our program from working. But note that you could try to recover from that error here. Instead of just saying, hey, there was an error and stop working, you could do something else here. In this class, because it's a first level programming class, that's all we require you guys to do. If you can't find the file, just say, hey, there's an error, and you just stop working. At first, students or any kind of programmer, they'll start getting angry that they have to catch these exceptions, right? I remember when I first started programming, I'm like, ugh, that's so annoying that I have to catch this exception. But in the long run, as you start programming more and more, you start appreciating these exceptions, because these exceptions are telling you what's wrong with your code and actually giving you a chance to fix it. So as you start appreciating and knowing programming more, you'll start appreciating these exceptions. And that's one of Java's main strong points, is that it has these exceptions and that it does make less breakable code because of these exceptions. You could see how this exception here would help your code, because if that file wasn't there, you now can recover from that error and do something else. So that was a long explanation of why we have this try-catch block. So in other words, we try to open the file. If it doesn't open, it comes down here, prints out an error message, and then exits the program. Now, if this has no problems, and it opens the file just fine, it'll skip that catch block. And it'll come down here to our while loop. So if there's no problems, it finds the file, it opens it, it'll come down here to the while loop. And what is our while loop doing? Our while loop is saying, okay, go to that file. This guy's connected to the file now. Input stream. And see if there's another line inside of that file. Notice that this is a method call. I know it's a method call because it has the parenthesis right here, right? Has next line. What value does this method return? It returns what kind of data type?
String.
No, not a string.
A Boolean.
A Boolean. And we know it returns a Boolean because it's put right there in the while loop. So note that even if I've never seen that method before, I know that that method returns a true or a false because of the way that this code has been written. And when do you think it returns true? When there's a next line in the file. And when does it return false? When there's no more lines in the file. Okay? So that's what that input stream has next line. It tells us, hey, there's a next line. You can go on with the loop. And once there's no more lines to read in from the file, this will return false, and then it comes outside of your while loop. Now we're just doing something really simple inside of the while loop. We're taking in that next line. Notice we just used the next line method. Hey, we've seen that next line method. We've used him all semester, the next line method. Okay. That next line grabs the next line out of our text file and places it into an object we called line, a string object. It then outputs that string to our console, comes back up here, sees if there's another line. If there's another line, it reads in the next line, puts it into our string object we called line, outputs it to the console. And notice it'll keep on repeating this until there's no more lines in our file. Now, very importantly, it closes that input stream at the end. After we're done using him, you don't want to close your input stream before you're done reading all of your lines from him. But at the end, he closes that file. What happens if you leave that file open?
You have a resource leak.
Yeah, you have a resource leak. And remember, a lot of you have asked me throughout the semester why that scanner keyboard, he always gave you that resource leak warning. Okay, if we've never closed him, it leaves a hole in your program, which could be a security error. Okay. Now, not closing a file can even lead to more errors. Okay, we'll look at those today when we're experimenting. Some of the errors that can happen when you don't close this file. But those are your steps. So your step one, declare this input stream as type scanner. Step two, put it in a try-catch block and connect him to your file name. Step three, read in from that file until there's no more lines and then do something with those lines. And then step four, you close your input stream. So just 4 steps. You make him, you connect him, you use him, and then you close him. All right. For example, Actually, we'll look at this today. But example, you could take this in as a string with next line. I could use next and read this part, and then I could say double, and then I could read it in as an integer. You don't have to always use next line. You can use next, and you can use next double, and you can use next int. Okay, so we could use all of the methods that we're already familiar with in that scanner class. Now let's look at our text file output. We'll actually do our output first in our experiments today. In our output, we do more or less the same thing when we're going to output something to a file. When we're going to output something to a file, a lot of it's copy-paste code again. First, we say our file name, whatever it is. Then we make our object, and this time we're making an object of type printWriter. Now there's different ways that you can output data to a file in Java, but we're going to use the printWriter object. Okay. So we make an object of type printWriter. So we declare him. And then we instantiate our printWriter object inside of our try-catch block, so that if something goes wrong, let's say we can't create this file for whatever reason, it'll go to the catch part, show our error message, and then stop our program. But if everything's okay and it makes this connection to that file, it'll then come down here. And in this example program, we have the user enter in some text, so a line of text. And in our for loop, we take in that next line with our keyboard scanner object. And then we just use this line of code here to output it to our file. It's output stream.println. It prints a number, which is the number we're using in our for loop, so it prints a 1 the first time around. And then it concatenates that with whatever the user typed in at the keyboard. And so it'll repeat that for 1, 2, and then 3. So it writes 3 lines of code to our file. And then very importantly, it closes the output stream and then gives a confirmation message to the user that those lines were written to our file. So note, it's very similar to how we set up our input stream. You declare him. Okay. You do a try-catch block to instantiate him. You then use that object, and then you close the object. All right. So are you guys ready to use him? And then we'll go through the rest of these methods after. So let's go ahead and jump right in. And the first thing we're going to do is write to a text file. So we'll keep our copy-paste code open. The first time around, yes, you are going to have to type this, but forever onward, you can copy-paste this code. It doesn't really change all that much. All right, so let's open up our IDE, our Eclipse IDE, and we'll just try outputting some text to our file. And we'll try some experiments here and learn about text files while doing this. And I must be logged in as somebody else on this computer today. All right. So this will just be kind of like a test. We'll try some tests out. And learn about text file input output. So I'm going to go ahead and make a new project folder. You guys can too if you want. This will be my text.io project folder. And And then whether you make a new project or not, go ahead and make a new class. Call it testing IO. And you can check mark that we want main inside of this program. And then remember to put your name at the top. I think most people that are left here in the class have this down pretty good. And the date. And then this is our testing file input output. And we can start to write this thing. All right. So first things first, we need to make a print writer object. Okay, this print writer object, we're going to declare him outside of the try-catch block and then instantiate him inside of the try-catch block. And we could try doing it different ways, and you can kind of see this is the only way that you can possibly do this. Okay? We want to declare him outside of our try-catch block so that we can use print writer object outside of our try-catch block. So you can name him whatever you want. I'm just going to name him output stream. And he's going to be initialized to null. And null for an object means that he does not have a memory reference. He does not hold an address. It just pretty much means that he's an empty object. Okay? And then go ahead and try to instantiate him. Remember that this is called, in fact, write good notes today. This is declaring our print writer object. Remember, this is called our print writer declaration, or declaring our print writer object. And then this is called our instantiation. When we use the new operator and we make a new object of this type, let's try doing it without the try-catch block. Now note that when we instantiate our print writer object, this is called our constructor, and our constructor takes in a string for the file name. So we could make a string explicitly like this, or just write this string inside of the file name. So we'll call it output.txt. Now note also that my print writer is red and underlined, and why is it doing that? You guys should be good enough that you know why it's doing that now in this class.
Yeah.
Right, he doesn't know what class that is because we have to import that class from the java.io library. So if you hover over print writer, the first quick fix tells us to import that class from the java.io package. Remember that that's a library of code with lots of classes in it. So this would be a class that we're inputting. Now it doesn't mind that we have the print writer object declared, but it does not like us instantiating this object. If I hover over print writer, he's telling me I have an unhandled exception, a file not found exception. This is why it frustrates students when they first learn Java programming and exceptions, because it's not going to let you do this without putting it into a try-catch block. It forces you to put it into a try-catch block. It's saying you cannot do anything else unless you take care of this exception. So it forces you to be a good programmer. It forces you to take care of if there was a problem here. Okay? So we could just go on the first quick fix here, add a throws declaration and surround with a try-catch block. We're going to surround with a try-catch block. So actually the second quick fix here. The first quick fix, add throws declaration, I'll do it and then I'll undo it just to show you what it does. Or you can do it and then undo it. but it throws that exception away, which is not a very good way to handle things. It says, oh, we'll just let the next guy take care of that problem. So it throws the exception away. Okay, but don't do that. So what we'll do is the second quick fix here is surround with a try-catch block. And it'll write that code for you. So note that we have our try, so our instantiation. So remember instantiation. So whenever you use the new operator, it's called an instantiation of a new object. Okay. So this is an instantiation of our print writer object. And that instantiation, of course, has to be in that try-catch block. Now note that we get to do whatever we want to do in this try-catch block, or in the catch part. So this means if we get to here, there was an error opening in our file. If this code is run, there was an error in opening that file. So note that if we ever get to this catch part, this part of our code failed. So if this part of our code ever fails, it's going to come here to the catch part. Okay. So we could output to the console and say error opening the file. And then they print what's called a stack trace, which tells you where you were in your program when these bad things happened. Okay, when it failed. And then what your book tells you to do is just go ahead and stop your program from working using the system exit 0. So this is the system class, the exit method. And you could put whatever number you want in there, but usually we could put a 50, which tells us if we ever have a 50, it failed right here in our program. Or you could put a 21 since we're on line 21. Whatever you want. All right. We'll try to get it to fail today, so you can see that code run. Now remember that that code will run if it fails. If it doesn't fail, it'll jump down here. So opening the file was successful. So if we ever get to this point in our program, opening the file was successful. That means it jumped over the catch part, and it's going to come down here. And now this output stream is successfully connected to the output file. That means the operating system did what it was supposed to do, and it makes that file for us and sets that up for us. Okay. Now we can have the user type in 3 lines of code and save it to that file for us. So we can tell the user, enter some lines of text. And we can enter in as many lines of text as we want. But let's just enter in 3 to start with. So we'll have a for loop kind of control that input for us. So we'll have the user type in those 3 lines for us. Now since the user is typing in lines of code, what do we need to get input from our keyboard? We need a scanner object like we've been using all semester to get input from the keyboard. Okay, so I'm going to declare our scanner object up here. So scanner keyboard equals new scanner, and we'll connect him to our system default input, which is our keyboard. All right, you guys should know that if you hover over scanner, you'll want to also import his library, java.util, and it puts that up there. Okay, now our input object of type scanner is ready to go. So I could say keyboard dot next line. You can grab, remember that grabs a string from the keyboard. Actually, I'll call him in. So we'll get the input from the user, and then we'll want to write it to our file. So write this input to our file. And we're getting the input from the user as a string. Now, to write it to our file is so easy. Once we got him all created, we can use the output stream object to write to our file. So you just put output stream and then use the dot operator because we're using this object to write to the file. And note all the methods we have available to us to write to a file. We have append. And what do you think we use to write to a file? We could use append. Everyone knows what append means, right? What does append mean? Yeah, to add to what's in the file already. So that wouldn't delete the file, it would add to the contents of that file. We can use him in a second. There's print line, there's to string, and then there's write. Okay. And if you hover over write, you should see a little yellow pop-up box. For whatever reason, my computer is not showing him today. But you can see what the write method does. This is a method. Okay. And just to show you, if that pop-up box, remember that this pop-up box is connecting to the Java API. And as you get better at programming, you should go and visit the API for whatever programming language you're using. And it's good to start looking at the Java API. So whenever you want to see the Java API, remember that the API is your application programming interface. It's more or less the directions to use Java. Okay? So if I wanted to look up any class in Java to get directions on using it, you just type in Java API and then that class name. It'll bring up the Java API. And it'll show you how to use this class print writer. Has a little explanation. And you can see in here that it has all of these methods, and these are the methods that Eclipse popped up for us. Here's the appends method. And if we look at that write method, the write method that takes in a string as its parameter, when we look at that write method, it says writes a string. This method cannot be inherited from the writer class, blah, blah, blah. So in other words, it writes the string to a file for us. Okay. But get used to looking up your methods as you're using them. You'll get better and better at programming. And the more that you look at this documentation, the more it starts to make sense. So good idea to look up all your methods. All right, now what do we want to write? We don't want to write this. What do we want to write? We want to write that string that the user typed in. So we just put the string inside of here as an argument. Remember that this is a method. This is an argument. When I look at the method declaration, this is called a, it's not called an argument. What is it called here? It's called a, starts with a P, parameter, right? This is the parameter. And then this is the argument. Remember that the argument is copied to the parameter and then used in the method. Okay. Note that we don't have to know how this method works. We just know that it does. And we just have to know what to send to this method to make it work. That's called encapsulation. Encapsulation, one form of encapsulation means we don't care how they wrote this method. We just care that it works. So it's encapsulated. And we just had to know to send it a string. All right. Now this should work. What did we forget? We forgot something. We forgot step 4. What was our step 4? Right. Now remember that we want to close it after we're done using it. So do not close your output stream in your for loop. In fact, we can try that next. You will see it fail if it tries to write again. You have to close your output stream outside of your for loop after you're done using him. So you never want to close him preemptively. Don't close your output stream too early. Always close him after you're done working with him. So when he's completed his job. All right, so we wrote our 4 steps out. Remember, I don't believe in memorization, but do remember what our steps are. We declare an output stream object, a print writer object, sorry. Then we instantiate him in a try-catch block. We use that object to write to the file. And then 4th step, we close the object. All right, so go ahead and run your code. If there's no other syntax errors, he should run. Remember that he's down here in the code now. He must have opened him okay because he got past that try-catch block. So since we've gotten past the try-catch block, that means that he did successfully open that file. Okay. So I can put the cat is fat, the dog is skinny, the dog eats the cat. And that was the end of my story because I only could write in 3 lines. All right. All right. So now is a good time to kind of pause and look at our code. Okay? And make sure everybody's is working for one. And then also, you might ask yourself, well, where is that file? I didn't get in a try-catch error. I didn't get my error. So it must have put it somewhere. And it put it here inside of your project folder. Now to see it, you just have to right-click your project folder and go to refresh or hit the F5 button for refresh. And when it refreshes this view, you can see that it did indeed create the output.txt. Note that he put them right outside of the source folder inside of the project folder. This is the default location of where it's going to create that file. So note that we answered a very important question too. If that file does not exist, what does Java do for us? It creates it for us. Okay. So double click on that file. You can open it up in your browser, or not browser, into your Eclipse IDE. And you can see that it did indeed write those things to our file. Now note that I wrote in the cat is fat, enter, the dog is skinny, enter, the dog eats the cat, enter. Now did it put my enter in here, my new lines? No, it didn't put my new lines in there. If I wanted to put a new line, do you guys know how you would make it put it in a new line? Yeah, there's a different ways that you could do it. You can concatenate it with the new line character. That's our new line character. Here, let's see if I put my slash the correct way. The cat is fat. The dog ate the cat. The dog is fat. And when I go and I look at my output.txt, you can see that he put those new line. Now since I put a new line at the end of my 3rd line, that's why I have this 4th line here. Okay, so now's a good place here to pause and make sure everybody's is working. And if you get yours working, your challenge would be to, how would you not have it print this last line out? So you do want this on its own line, and you want this guy on its own line, and you want this guy on its own line. How would you get it not to print out this last 4th empty line? See if you can figure out how to get to not print the last fourth empty line in your output. And I'll pause and make sure everybody's is.
So to put that new line in there, just add the end of line character into your output stream.write method. It concatenates the end of line character onto that output stream. And then use an if statement to check if we're on the last loop. And if we're on the last loop, or not on the last loop, then we'll go ahead and print out the end of line character. Otherwise, we just print the output stream without the end of line character. And that's how you solve that last problem where we want the output to output the end of line character until we get to that last line, and then no end of line character. That's how you would solve that last part of the problem. Make sure you test that part of the code by giving some sample input into your program and then looking at the resulting file to see if that actually worked, which it should. And as you can see, the last line doesn't have an end of line character after it, so it doesn't print that new line at the end of your file. Alright, now let's print something more interesting to our file. So we're going to print some numbers to our file. But before we do that, let's comment out our output stream.close and see what happens to our output file when we comment out or leave out the close method and don't close our file. Comment out the output stream.close and then run your code. Give it some sample input and see if our file will still be the same if we forget to close it. So run your code, and as you can see, our output.txt does not get print properly to our hard drive. And this happens because our output.txt is actually on an output buffer inside of our operating system. And the output buffer is pretty smart in our operating system, and it tries to be efficient. And it won't actually write to the hard drive until the output buffer is full. This makes for a more efficient way of writing things to the hard drive, because writing to the hard drive is such an expensive process. And so if you do not close your output stream, then your operating system never writes to the hard drive and never outputs that output buffer to your hard drive, because the output buffer never got full. When we close our output stream, we're forcing the output buffer of our operating system to write that file to our hard drive. Now let's try to make our code not work by trying to write to a part of the operating system where we're not allowed to write. And on these computers inside of our lab, we're not allowed to write anything to our hard drive. Our hard drive is called our C drive. And so if I put our C drive here in our print writer connection and we try to write to a text file that's directly on our hard drive, it will throw a file not found exception because we are not allowed to write to our hard drive. On your home computer, you might be able to write to your hard drive, so this might not fail. Alright, now let's try changing our file extension to something other than .txt. Let's try changing it to .png or .ping. This is a photo file extension that we usually use for photos. And what I want to show you here is that it doesn't matter what our file extension is. Our file extension has no effect on what is stored inside the file. Text will still be stored inside of our file, and Java could care less that that we are writing some text to a file that we have a file extension of .ping. The only part that cares that we have a file extension is our operating system when we go to try to open the file. And on these computers in the lab, the default application that tries to open a .ping is Fireworks, which is an Adobe program. So when I go to refresh, so always right click on your project folder to refresh that project, you'll see this new output file that it created, output.png. You can see that on these computers in the lab that Fireworks is the default program because of the little icon for Fireworks. And when I double click on this folder, it will try to open it with Fireworks. Now that doesn't make this file a .png. This file still is a text file. The file extension has no real bearing on what's inside of the file. It only tells the operating system what program to open this file with, or try to open this file with. I can right click on this file and still open it as a text file. I can even give the file a file extension name like .kanemoto. Remember that this does not change the contents of the file. Text is still being written to this file. The only thing that I've done now is I've told the operating system that it doesn't know how to open this file by giving it that file extension. So just remember that file extensions play no real role on what data is stored inside the file. It only plays a role in how your operating system decides to open that file. Now go ahead and change your file name to numbers.txt. And then we're going to go ahead and we're going to write something different to our file. Let's go ahead and write a whole bunch of random numbers to this file. Go ahead and comment out the rest of the lines in that for loop. We were just testing that code anyway. Now let's try writing a bunch of numbers, random numbers, to our file. Let's try writing 5 million random numbers to our file. So we'll make our loop run 5 million times, and then inside of this loop, we're going to write a statement to create a random number and write it to the file. Now go ahead and try to open that file after you've written 5 million numbers to it. Now on the computers in the lab, when we go to try to open that file, it's not going to let us because the file is too large. So you could try writing a few less numbers to your file if that happens to you. Another way that you could open this file is by going to the file folder and right-clicking on it and opening it with a different program that is able to open a file with 5 million numbers inside of it. Inside of the labs, we're going to use Notepad to open this, so I'll go to the file folder, right-click on that file, and ask it to open it with Notepad. Now go ahead and make a new file. We called it testing file io_2. Made a new Java file, and then we copied the code from the slides or from the textbook into this file to read from the file. Note that you'll have a scanner input stream, a scanner object to read from your file, and then you'll have that try catch block to catch a file not found exception if we do not have access to this file. And then we have this while loop down here that's going to read our input from our file while there's a next line inside of our file. So you can use the same file or create another file. I am using output.txt that just has a few numbers inside of it, not the 5 million numbers, which would take a really long time to print to our console output. So go ahead and make an output.txt file that just has like 5 or 6 or even 10 numbers inside of it. You can try it out without numbers at first, so go ahead and try it with some text. You can see our output.txt right there had some text inside of it. And remember that your scanner object is the same scanner object we've been using all along in class. And we named our scanner object input, and so you can see right there that it was input.nextLine, and it was grabbing those lines in there as strings. I'm going ahead and put some numbers in our file, and I'm going to go ahead and get that input from our file as integers now. So which method do we use with our scanner object to grab integers? That's right, nextInt. We know that that pulls in an integer, so we need to take in that input as an integer. So we go ahead and take in our input as integer, call our nextInt method, and it grabs those integers from our input file. And note that the last input was not an integer in our input file. As you can see from that input file, my last line was empty, and when it went to go and find the integer from that file, it said, hey, there's no integer here anymore. There's just an end of line character, and that's why you get this runtime error. To get rid of this runtime error, just get rid of that empty line inside of your input file. Once you get rid of that empty line in your input file, then you won't have that runtime error anymore.